The universe is incomprehensibly vast, so much larger than anything we, as humans, can truly grasp. Every year, we take a step closer to unraveling its many mysteries, and this past decade has been especially groundbreaking, with discoveries that are nothing short of awe-inspiring. Just this year alone, NASA has confirmed over 5,000 exoplanets, planets that orbit stars far beyond our solar system. These planets vary greatly, from super-Earths, planets larger than Earth, to gas giants like Jupiter, to ice giants like Neptune, and many other strange and unique worlds we never even thought possible. But here's the kicker. Despite the impressive discoveries we've made, scientists believe that the Milky Way galaxy alone contains over 1 trillion exoplanets. Yes, you heard that right, 1 trillion. Among the hundreds of new worlds we've discovered, one stands out not just for its size, but for the complete rethinking it prompts about how planets form. This giant exoplanet, so massive it dwarfs even our nearest neighbors, is completely altering our understanding of planet formation. So, let's dive into what makes this planet so remarkable and why it has scientists scratching their heads in amazement. Enter B Centauri b, a true cosmic giant. This behemoth planet, called B Centauri b, also known as B Centauri b, has captured the attention of astronomers worldwide. Discovered relatively recently, B Centauri b is so large and unusual that it has completely challenged our knowledge of planetary science. It resides in a region previously thought to be too hostile for a planet to form. B Centauri b orbits a pair of extremely hot stars located in the Centaurus constellation. This star system is fascinating in its own right, as it's one of the hottest, most massive systems discovered to date, and it's where B Centauri b defies expectations. The European Southern Observatory captured spectacular images of the planet using its very large telescope in the Atacama Desert of Chile. Before this discovery, no planets were thought to exist around stars more than 3 times the mass of our Sun. But B Centauri b is living proof that sometimes the universe doesn't follow the rules we set. Now here's where it gets mind-blowing. B Centauri b is 10 times as massive as Jupiter, making it one of the largest planets we've ever found. And what makes it even more astounding is the environment it inhabits. Massive stars like those in the B-type star category emit intense ultraviolet and X-ray radiation, which scientists believed would make it nearly impossible for planets to form. These stars were thought to be too destructive for planet formation. But B Centauri b's existence has turned that theory on its head. It proves that, in some cases, planets can indeed form in extremely hostile environments, those that we once thought were unsuitable for planet growth. This discovery is fundamentally changing how scientists view the relationship between stars and their planets. An orbit like no other the size of B Centauri b isn't the only thing that sets it apart. The planet's orbit is absolutely massive. It is 100 times farther from its star than Jupiter is from the Sun. To put that in perspective, it's like the difference between Earth and the farthest reaches of the Kuiper Belt. This great distance likely protects the planet from the intense radiation emitted by its parent stars, allowing it to survive in what would otherwise be a harsh and inhospitable region of space. One of the leading scientists on this discovery, Mark Jansen from Stockholm University, explained that this finding could have massive implications for our understanding of how planets evolve around stars of such extreme masses. The team now believes that there are far more planets that can survive around these hot, massive stars than we initially thought. The role of disk instability in planet formation. Now let's turn our attention to another giant planet that is also 9 times the size of Jupiter and is in the process of forming in a very violent and dramatic way. This planet, known as a B Origi b, was observed using the Hubble Space Telescope, and it offers a fascinating glimpse into how some of the most massive planets come into existence. Planet formation, in general, is often compared to cooking. Just like making a meal, the ingredients, gas and dust, and the process, how gravity pulls everything together, can vary greatly. With a B Origi b, scientists have observed disk instability, a process in which the protoplanetary disk, the swirling cloud of gas and dust around a young star, rapidly collapses, forming a planet almost overnight. At only 2 million years old, the star at the center of this system is still a baby in cosmic terms. The protoplanetary disk around it is rich with dust and gas, but instead of slowly gathering material over time like we see in the formation of Earth or Jupiter, this planet formed much faster, thanks to disk instability. This violent process creates planetary fragments that quickly grow into massive worlds. AB Origi b orbits its star at a mind-blowing distance of 8.6 billion miles, which is more than twice the distance from Pluto to the Sun. Despite being far out, the planet is about 9 times as massive as Jupiter. This discovery challenges the traditional understanding of how planets form. While conventional theories suggest that planets gradually accumulate mass, the disk instability model proposes that massive planets can form in an instant, thanks to the collapse of the surrounding disk. TOI 849b. The rocky mystery. Another perplexing planet discovered by NASA's TESS mission is TOI 849b, a rocky world that's unlike anything we've seen before. Found approximately 730 light-years away, TOI 849b is a truly strange world, and it's one that doesn't fit neatly into any of our existing categories for exoplanets. TOI 849b is the largest rocky planet ever discovered, and yet it has some features that make it seem like a gas giant. But here's the twist: it's exceptionally dense and seems to lack a thick atmosphere. Scientists believe it may actually be the exposed core of what was once a gas giant planet, which failed to fully develop its gaseous envelope. This makes TOI 849b one of the most unusual planets scientists have ever encountered. Despite its rocky composition, TOI 849b weighs in at a staggering 40 times the mass of Earth. This is way too heavy for a planet of its size to form through the usual process of gas accumulation that leads to the formation of gas giants like Jupiter. Instead, scientists believe that something went wrong during its formation, leaving behind a dense rocky core that should have been surrounded by a massive atmosphere. TOI 849b orbits its star in just 18 hours, and its surface temperature soars to 2,800 degrees Fahrenheit, about 1,500 degrees Celsius. This extreme heat, combined with its extraordinary density, raises numerous questions about how planets